Okay, year 13. Here is a harder example, as I promised, of how to integrate a rational function in the form like that. Okay, now that looks pretty awesome because you've got an x cubed on the top and you've only got 2x on minus 1 on the bottom. But we can do long division to break this up and then integrate it. Okay, so how do we do this? Well, this 4x cubed minus x plus 1 is being divided by this 2x minus 1. So we write it like this. We write the 2x minus 1, the thing that's doing the dividing out here, draw that little funny bar thing, and we put the polynomial underneath. Now immediately you will be jumping up and down saying, hey, wait a second, there's something strange about this, because I've gone and written a 0x squared. What on earth am I doing? Well, why I'm doing that is because you will notice, I hope, from the layout of this, that I've got a column with all my x cubes in. And then I've got a column with all my x squareds in. And then I have a column with all my x to the power 1 in. Now these I've called power columns, if I've written it like that. And it's much easier if you can see this systematic way, because if you do this, it will make things much easier to see what you're doing than if you just plonk answers down on the top here in any sort of order, without some sort of order. Okay, so what do we do? Well, the first thing we do is we take the highest power, the term with the highest power here, and we divide it by the term with the highest power here. And in this case, it just has to be 2x. So what we're actually beginning with is we're beginning with this little division here. We're saying 4x cubed, that's that thing there, divided by 2x, that thing there. So this x is going to bring that down to x squared. The 2 goes into the 4 twice. And the answer we get is 2x squared. Now, we do not write the 2x squared over the 4x cubed because it's in the wrong column. We write it here over the x squared column. Okay? Let's see what we do now. Well, we've got the answer 2x squared, and we now multiply this back to each one of these terms here. The first one, of course, is the 2x here. So we're going to go 2x squared multiplied by 2x. Well, that's going to give me 4x cubed. Well, I must write it in the cubed column, so it goes there, 4x cubed. Now I multiply this 2x squared by the minus 1, which is going to give me minus 2x squared. Now you can see we're keeping things nicely in the x squared column. We're keeping things nicely in the x cubed column. Now we draw a line and we now subtract. Well, remember, put this in brackets. Think of that as being in brackets because this minus sign and that minus sign is going to produce a sign change. So we subtract column by column. So we're going to say 4x cubed minus 4x cubed. Well, that goes to 0. And now we're saying 0x squared minus 2x squared. Well, this minus and minus are going to go to plus, and in that case we're taking away nothing from it, so it just goes to 2x squared. Now we bring down this minus x to the power 1. There it is. I've brought it down to there behind the 2x squared. And now what do we do? Well, we take the term in here with the highest power, which is 2x squared, and we divide it by the 2x there. And I've shown that down here. There it is. I've got this 2x, this plus 2x squared there. and I'm dividing it by the highest power of the x in this thing here, which is 2x. Well, this x brings this x squared down to x to the power 1, and these 2's cancel out. Well, they become 1, which is the 1x to the power of 1. And so we write our answer, this is positive, we write our answer here, plus 1x to the power 1, nicely in the x to the power 1 column. Now we multiply this back to both of these terms there and there. So x to the power 1 times 2x to the power 1 is going to give me 2x squared. So I write that down here in the x squared column. Now I write, now I multiply this x to the power 1 with this minus 1 there, and that leaves me with minus x to the power of 1 there. Now don't forget, we are subtracting this. Put them in brackets. So this is going to be 2x squared minus 2x squared. Well, that's going to go to 0. Now we've got to be very careful here because of the sign change. This minus x here is going to go minus x there. And that minus and this minus are going to go to plus. So we've got minus x plus x, which is going to go to 0. Okay, so they all disappear, and we bring down this one. This is our remainder. And just as before, when our remainder in the numerical example was 2, and we were dividing by 5, we wrote 2 over 5. Our remainder now is 1 over this 2x minus 1. There it is there. So when we divide this thing here, when we do this division here, we get this answer here plus this remainder like that. And that, of course, can be integrated. All of this can now be integrated. Okay, so let's see how to do that. Well, there we have it. They're asking you to integrate this. You do long division on the integrand and you break it up into that. Okay, so you're being asked to integrate this. So we can now integrate each of these terms separately. That one, and that one. So what does that look like? Okay, well, what it looks like is this. If you integrate 2x squared, you get 2x cubed over 3. You're all able to do that now nice and quickly. If you integrate x to the power 1, you get x squared over 2. And this one here may prove a little bit trickier, but what you're doing is you're integrating 1 over 2x minus 1 dx. Well, what you do is you say let u equal this denominator of 2x minus 1, differentiate, you get du by dx is 2. So if I cross multiply the dx there, I'm actually multiplying. If I multiply the dx by 2, it will stand for du. So that's what I've gone and done here. I've pre-multiplied the dx by 2, but to keep the value of the integral the same, I've got to divide by 2 at the same time. Now this division by 2 I can bring to the front there and write 1/2 the integral of 1 over u du. And that, of course, is the natural log of u, and u we said was 2x minus 1. So you just replace the u with the 2x minus 1. So our final answer to this integration here is equal to 2x cubed over 3 plus x squared over 2 plus 1/2 of the natural log of the absolute value of 2x minus 1 plus the constant of integration. Okay, I hope that was fairly clear. I'm going to upload some examples from the book for you to try yourself. This particular one here is example 12, but there are some others which are just as tricky as this. But anyway, have a go and see if you can get your answers. Any problems, please don't hesitate to alert me on Teams and I'll try and sort you out. Okay, thank you very much.